Welcome to this explainer. Okay, today we are looking at one of the absolutely most epic mysteries in the entire history of human knowledge. We're talking about how we actually managed to organize the fundamental building blocks of the universe into a single elegant system. It's this crazy story of chaotic early discoveries, just brilliant intuition, and ultimately a tragic young genius who used cutting-edge physics to solve the puzzle once and for all. So, how did humanity organize the sheer chaos of the universe into a single table? Let's dive right into this. Imagine looking at literally everything around you: the air you're breathing, the metal inside your phone, the carbon in your own body. Trying to categorize every single physical substance in reality, that is a mind-boggling task. For centuries, scientists were basically staring at a giant pile of puzzle pieces with no box, no picture to guide them, nothing. So how did they find the hidden rhythm of nature? Well, to understand the solution, we first have to understand the problem. Section 1, the chaos of the elements in the 18th and 19th centuries. You see, early chemistry was basically organized chaos. Back in 1789, Antoine Lavoisier tried this super simple grouping of metals versus nonmetals. Then, about 40 years later, Johann Dobereiner noticed that certain elements came in these triads, or groups of three, that shared similar properties. Fast forward to 1862, Alexandre-Émile Béguet du Chancourtois tried wrapping elements around a cylinder in this weird helix shape. And in 1864, Julius Lothar Meyer grouped 28 elements by how they bonded with others. You can see how this rapid evolution of chemistry reveals how desperately these scientists were trying to find a pattern. They were all kind of circling the truth, but they totally lacked a unified predictive system. Which brings us to 1869. Section 2, Mendeleev's vision, or what I like to call a chemical solitaire. Enter an eccentric Russian chemist named Dmitri Mendeleev. So Mendeleev was absolutely obsessed with organization. Legend has it that he essentially played chemical solitaire on these long train rides. He would write the chemical properties and atomic weights of the 63 known elements onto blank cards, and he'd just endlessly arrange and rearrange them. He was looking for the hidden rhythm of nature, right? And he eventually realized that if you ordered them by increasing atomic weight, certain chemical properties actually repeated themselves periodically. But here is what made Mendeleev a true visionary. When his sequence of atomic weights didn't match the chemical properties he was expecting, he didn't try to force it. Instead, he did something incredibly audacious. He just left a blank space. He boldly declared that an element definitely belonged there, but humanity just hadn't discovered it yet. He even predicted their exact properties, naming them things like Eka aluminum and Eka silica. And no joke, years later, when gallium, scandium, and germanium were discovered, their properties perfectly matched Mendeleev's predictions. The scientific world was absolutely stunned. But as amazing as it was, Mendeleev's masterpiece wasn't perfect. Section 3, the enigma of weights, and a glaring flaw. This perfectly illustrates the massive headache scientists were wrestling with. Mendeleev based his entire table on atomic weight, meaning how heavy the atom was. But look at cobalt and nickel. Cobalt is technically heavier than nickel, so if you follow the rule of weight strictly, nickel should absolutely come first. But if you arrange them by their actual chemical properties, putting nickel first completely breaks the groupings. So what did Mendeleev do? He just swapped them anyway based on his gut intuition, essentially breaking his own rule. The table worked like magic, but nobody actually knew why until a massive technological leap occurred. And that leap finally arrived in 1913. Section 4, Moseley's X-ray breakthrough. Enter a brilliant 26-year-old British physicist named Henry Moseley. Now, what's really interesting about this is exactly how he unlocked the universe's secret using a brand new invention, the X-ray spectrometer. Here is how he predicted new elements with such insane scientific precision. Step 1. Inside a vacuum tube, he fired high-speed electrons at a pure sample of a metal, like copper or gold. Step 2. This collision energized the inner electrons of the metal, causing them to emit X-rays. Step 3. He used a crystal to bend and measure the exact wavelength of those X-rays. It's kind of like striking a bell and measuring the exact pitch of the ring. Every single element rang with its own unique mathematical frequency. And when Moseley plotted the square root of these X-ray frequencies against the sequential order of the elements, the result was just breathtaking. It wasn't some messy scatterplot. It was a perfect mathematical straight line. A beautiful ascending staircase. This became known as Moseley's law. It proved experimentally that an element's position on the periodic table wasn't just some random sequence number we made up, but a real, measurable physical property tied directly to the positive charge inside its nucleus. This single discovery literally changed everything. Section 5. The DNA of atoms and atomic identity. To really wrap our heads around this, let's use an analogy. Think of atomic weight kind of like a person's physical weight or the clothes they're wearing. It can fluctuate, right? In chemistry, atoms of the exact same element can actually have different weights. We call those isotopes. But in contrast, the atomic number is like your DNA. It's your national ID card, like a CPF or a permanent barcode. It is your completely immutable, unchangeable identity. So before Moseley, atomic number was just a tag. It was like saying you're the 15th person waiting in line. But Moseley redefined it as a strict physical law. The atomic number is the fundamental identity of an element, based exactly on the number of positive protons in its nucleus. Hydrogen has 1 proton, helium has 2, and so on. If you change the protons, you literally change the element entirely. So, the crucial point is this. Moseley completely reorganized the periodic table by atomic number instead of atomic weight. And instantly, all those old problems just vanished. That confusing cobalt and nickel inversion fixed. Cobalt has exactly 27 protons and nickel has 28, so cobalt definitively comes first, completely regardless of its weight. What about that really messy group of rare earth metals? Well, Moseley scanned them with his X-ray spectrometer and proved once and for all there were exactly 15 of them. Mendeleev's incredible intuition was finally backed by the hard, undeniable mathematics of subatomic physics. They basically built the modern table together across time. And because Moseley's mathematical staircase was so perfectly precise, he could literally see exactly where steps were missing. Between aluminum and gold, he found exactly 4 missing gaps. Elements 43, 61, 72, and 75 simply didn't exist yet, and he predicted their existence with absolute, unquestionable mathematical certainty. The guy was on track for a guaranteed Nobel Prize. But then, history took a really dark turn. Section 6, the cost of war. In 1914, World War I erupts across Europe. Moseley was actually offered a safe, super prestigious professorship at Oxford where he could have easily continued his groundbreaking work in the lab. But driven by this profound sense of patriotic duty, he refused. He volunteered for combat and marched straight to the front lines as an officer in the Royal Engineers. And on August 10, 1915, during the brutal Battle of Gallipoli, Henry Moseley was shot by a sniper and killed instantly. He was only 27 years old. The aftermath of his death was just monumental. Over the next 3 decades, scientists used his exact X-ray methods to finally find those 4 elements he predicted: technetium, promethium, hafnium, and rhenium. Meanwhile, the British scientific community was deeply, deeply outraged by his death. The loss was considered so severe that the British government and eventually militaries worldwide actually changed their policies permanently. They decided they had to keep elite scientific talent off the front lines and assign them to research behind the scenes instead. His mentor, the Nobel laureate Ernest Rutherford, perfectly captured the heavy grief of the global scientific community when he wrote, "The loss of this young man on the battlefield is a striking example of the misuse of scientific talent." Isaac Asimov would later call it the single most costly death of the entire war. Which leaves us with a final, honestly haunting question. If Henry Moseley could decode the literal DNA of the universe by the age of 27, what else could he have discovered if he had survived? It's wild to think about. But thanks to Mendeleev's raw intuition and Moseley's brilliant precision, we finally have the modern periodic table we use today. Thank you so much for joining me for this explainer. Stay curious and keep exploring the amazing patterns of our world.